Okay guys, let's use the factor theorem and what we know about long division to help us solve for some unknown coefficients. So the example I'm going to start with here is question 2. If x minus 4 squared is a factor of x cubed plus px plus q, find the values of p and q. So let's have a look at this. So we have x minus 4 squared is a factor of x cubed plus px plus q. So that means that x minus 4 squared divides into x cubed plus px plus q evenly. So the first thing I'm going to do to simplify it out is just work out my x minus 4 squared. So that's going to be x minus 4 times x minus 4, x squared minus 4x plus 16. So x squared minus 8x plus 16 is the same thing as x minus 4 squared. So I'm going to use that. I've got my x squared minus 8x plus 16, and that is a factor of x cubed plus px plus q, so therefore it divides evenly into x cubed plus px plus q. Don't forget, when you're doing some long division, you need to have all your columns. So even though they didn't give us an x squared, we put in a 0x squared because we've got 4 columns in our long division here, and we need to keep all 4 columns aligned correctly. So this divides evenly in here. So let's just start off, do our division and see how we get on. So x squared into x cubed, that goes x. Then multiplying x by these guys is going to give me x by x squared is x cubed. X by minus 8x squared. And x by 16 plus 16x. Then I change my signs. It becomes a minus, that becomes a plus, that becomes a minus. And my next line, x cubed takes x cubed. That's gone. 0x squared plus 8x squared is 8x squared. Now, px minus 16x, right? I just want to talk about this a little bit. You could say plus px minus 16x, but this is a bit untidy here. As I already said, we have columns. We would like to keep our columns aligned, and we would like to only have one term in each of the columns. So rather than using px minus 16x, my advice to you is just do a small bit of factorizing. So for example, px minus 16x, if you factorize out the x, you'll have p minus 16. So the way I like to look at it is p minus 16 is the coefficient of x in this case. So rather than calling it px minus 16x, I'm going to call it p minus 16 times x. And then we haven't used the q yet, so plus q. Right, let's continue with the division. So x squared into 8x squared, that's plus 8. Then we're going to multiply the 8 by all of this. So 8 by x squared is 8x squared. 8 by minus 8x, we've got minus 64x. And then 8 by 16 plus 128. All right, so change my signs, minus, plus, minus. Now here we have to recognize that the division is in fact done. We've divided x squared into x squared. There's no more division to be done. And if x minus 4 squared is a factor, we should have no remainder down here. It should divide in evenly. So every column should technically tidy up to 0. Each column separately should tidy up to 0 because we're not supposed to have any remainder. And we can see the first column here, 8x squared minus 8x squared, that is 0. But the second column here, the x column, p minus 16x plus 64x should be 0, and q minus 128, that should be 0. So we can use this to help us figure this out. So what did we say? We said that p minus 16 times x plus 64x, this column here, that's supposed to tidy up to 0. And similarly, the last column should also tidy up to 0. So the last column, q and my minus 128, that should also tidy up to 0. So we're going to take this with us and use it on the next page to help us figure out the values for p and q. So p minus 16x plus 64x equals 0. Let's just divide this by x since we don't care about x. We want to solve for p and q, so we can divide through by x because x is in every term here. And we would have p minus 16 plus 64 is 0. So p plus 48 is 0. So p is equals to minus 48. So there's my value for p. P is equals to minus 48, and clearly we can see if q minus 128 equals 0, then q must equal 128, and there is my value for q. So that was fairly straightforward. Let's just have a quick recap of what we did there. We were told that x minus 4 squared is a factor of x cubed plus px plus q. And we squared this out, and we long divided our x squared minus 8x plus 16 into our x cubed plus px plus q, remembering the 0x squared because it wasn't given to us. And after we had division done, we realized each column should tidy up to 0 because there shouldn't be any remainder. So the p minus 16x plus 64x should be 0. And the q minus 128 should be 0. And that is where we got these equations here to help us solve for p and q. All right, let's look at another example here. So the next one I'm going to do for you guys is let's have a read here of question 6. So if x squared plus ax plus b is a factor of x cubed plus 7ax squared plus 4bx plus c, show that b is 2a squared, c is 12a cubed. So we're not actually asked to solve for any values here. We're just asked to show these identities or prove these small identities. So x squared plus ax plus b divides evenly into x cubed plus 7a squared plus 4bx plus c. So let's do our division again. So x squared and x cubed goes x. Then we multiply our x by our x squared plus xb. So x by x squared, that's x cubed. X by ax, that's plus ax squared. And x by b is plus bx. Then I'll change my signs. So there we'll cancel. So 7ax squared take ax squared, that's 6ax squared. 4bx take bx, that's 3bx. And then we carry down the plus c because we still have to use that. So let's continue with our division. X squared into 6ax squared, that's plus 6a. Then I'll multiply 6a by this. So 6a by x squared, that's 6ax squared. 6a by ax would be 6a squared x. And then 6a by b would be 6ab. So once again, I'll draw my line and change my signs. So now we're at the stage where the division's done. X squared has been divided into x squared. There's no more division to be done. And since we were told that x squared plus ax plus b was a factor of this expression, we know it must divide in evenly, therefore leaving no remainder. So we know that each of our three columns, the x squared column should tidy to 0, the x column should tidy to 0, and the constant column should tidy to 0 since there's not meant to be any remainder. So we can see that works for the x squared. 6x squared takes 6x squared is definitely 0. So the x column is supposed to tidy up to 0. So this tells me that 3bx minus 6a squared x, that's supposed to tidy up to 0. And similarly, c minus 6ab, that's supposed to tidy up to 0. So these are our two equations that we can use. And we can use these equations to help us prove whatever we were trying to prove. Now the thing is, let's not lose track of what we were actually trying to prove here. So let's go back to the question sheet here. What we were trying to prove is that b is 2a squared and c is 12a cubed. So we were trying to prove that b is 2a squared and c is 12a cubed. We start off with our first equation here, 3bx minus 6a squared x equals 0. So once again, we don't care about what x is in this one, so we can divide by x, and we will end up getting 3b minus 6a squared is equals to 0. In other words, 3b equals 6a squared, and then divide across by 3, b is equals to 2a squared. So we have proven the first bit. B is equals to 2a squared. Now we have to also prove that c equals 12a cubed, and that's going to come from this one. So working with this one, we can say we've got c minus 6ab is 0. So in other words, c is equals to 6ab. But we're trying to prove that c is 12a cubed, not 6ab. What we're trying to prove doesn't have a b in it. But if we go back here, we already know that b is 2a squared. So subbing in 2a squared in for b, we'll get c is equals to 6a by 2a squared. In other words, c is equals to 12a cubed. And that is the second one proven. That is how you use the factor theorem and long division to solve for unknown coefficients. What you guys should do now is practice some of these questions, check your solutions. And for access to questions, solutions, graded quizzes and more, visit www.linearmaths.com.